Hello everyone, myself Navi Abral, a BSc Honours Chemistry student of Kirodimal College from Delhi University. Today I am going to present an organic chemistry practical which aims at to carry out the partial reduction of meta-dinitrobenzene to meta-nitroaniline. So let's carry out this experiment. The apparatus required are meta-dinitrobenzene, crystallized sodium sulfide, finely powdered sulfur, concentrate HCl, dropping funnel, burner, beaker, stirrer as well as water. So the theory is meta-dinitrobenzene is selectively reduced with ammonium sulfide to form meta-nitroaniline. So the reaction involved is meta-dinitrobenzene on reaction with ammonium sulfide gives meta-nitroaniline, as well as some side products are also given out like ammonia gas, water and sulfur. Now, the question arises that why partial reduction? So, meta-nitroaniline is an important intermediate for the preparation of dyes, electrical and mechanical corrosion inhibitors, urethanes, and pharmaceuticals. Due to these industrial applications, meta-nitroaniline is prepared. In this reaction, out of two nitro groups, only one nitro group gets reduced because if both nitro groups get reduced, then diaminobenzene is formed instead of meta-nitroaniline. But we don't require diaminobenzene, hence partial reduction is carried out. That is, only one of the nitro group gets reduced and the other will remain as it is. Now, generally, meta-nitroaniline is produced from the partial reduction of meta-dinitrobenzene with disulfides or metal acid systems. Hence, sodium sulfite can also be used for this reduction. It can also be produced by the acetylation of aniline and then nitration with subsequent removal of acetyl group by hydrolysis. Both of these two methods are hazardous and costly with further separation and waste disposal, but we prefer the partial reduction method because meta-nitroaniline can be obtained by this method in less number of steps and hence it is less time consuming. Now, the mechanism involved. So, the mechanism involved in this reduction is well known as electron transport mechanism. So, let's discuss. What will happen here? The nitro group of the dinitrobenzene will take up hydrogen from the water molecule to form this OH bond, and the double bond of the oxygen will get pass on to the second oxygen, and hence it will get a lone pair of electron and a negative charge. Now in the second step there is a loss of OH minus, and the OH minus which is lost will attack on the hydrogen, and the hydrogen will break its bond from nitrogen, and hence the loss of water molecule takes place. Then after the water molecule loss, we get a compound which is well known as nitroso. This nitroso is then converted into the phenyl hydroxyl amine, and then this phenyl hydroxyl amine upon again reaction with water will form meta-nitroaniline, which is a desired product. So this is the mechanism related to this reduction. So now the question arises that which nitro group will get reduced. So there are two different cases. First is in substituted dinitro and trinitrobenzene, the least hindered nitro group is preferentially reduced. The least hindered nitro groups mean that around which there is no other group. So in this example, the least hindered nitro group is this one because it is free from all the sides, whereas this nitro group is accompanied by the methyl group. Hence, this nitro group will get reduced into the amino group and the other nitro group will remain as it is. Now, the second case, in dinitro and trinitrophenols and their ethers, in nitro group, ortho to the hydroxy or alkoxy is preferentially reduced. So in this example, I have taken the alkoxy group. So this nitro group is attached with this alkoxy group and hence it will get reduced into the amino group and the other will remain as it is. So now procedure. Prepare a solution of sodium polysulfide by dissolving 1.6 gram of crystallized sodium sulfide in 10 ml of water, adding 0.4 grams of finely powdered sulfur and warming until a clear solution is obtained. Heat a mixture of 1 gram of dinitrobenzene and 12 ml of water contained in a 100 ml of beaker until the water boils gently. Stir the solution mechanically through the whole process. Now place the sodium polysulfide solution in a dropping funnel and clamp the funnel so that the end of the stem is immediately above the beaker. Add the sodium polysulfide solution during 30 to 45 minutes to the vigorous stirred boiling mixture and boil gently for a further 20 minutes. Allow to cool. This can be accomplished more rapidly by adding ice. Then filter and wash with cold water. Transfer it to a 250 ml beaker containing 6 ml of water and 1.4 ml of concentrate HCl and boil for 15 minutes. The metanitroaniline dissolves, leaving the sulfur and any unchanged dinitrobenzene. Filter and precipitate the metanitroaniline from the filtrate by the addition of excess of concentrate aqueous ammonia solution. Filter off the product and recrystallize it from the boiling water. The yield of metanitroaniline, which is in the form of bright yellow needles, is calculated and its melting point is determined. So now the metanitroaniline which is formed is very less in quantity. So the question arises is that the yield of the metanitroaniline obtained is very less. Why? So electron withdrawing groups deactivate the benzene ring, hence reaction yield lowered. Hence very strong conditions are applied but still 57% yield is obtained. Like this is dinitrobenzene and it is converted into the metanitroaniline, but we get only 57% of the yield because here the electron withdrawing NO2 group is attached, so it will deactivate this benzene ring and hence the yield is very less. So electron donating groups like CH3 activates the benzene ring, hence reacts easily with effective yield. So if there is any electron donating group like CH3 or any other, then we get effective yield. Otherwise, the yield is lowered. Now, some important points. Nitroaniline formed reacts with HCl to form anilinium chloride, which is a salt, and hence gets completely dissolved in water and sulfur is left. So, anilinium chloride is a salt. Hence, in order to neutralize this salt, we have added the ammonia solution as mentioned in the procedure. And here sulfur is used to increase the rate of the reaction. So this is the general reaction involved, that metanitroaniline react with HCl and form anilinium chloride, which is a salt, and hence ammonia is added in it to neutralize it as well. Now The result, the yield of the synthesized fruit matter nitroaniline and the melting point of the recrystallized sample is calculated in the degrees Celsius. Now what precaution we have to take, that the crystalline sodium sulfide is very deliquescent, hence reasonably dry should be used. So thanks and have a nice day.